Lesson 11.3, which is the last lesson, is the binomial theorem. So a recap from the last class, which is 11.2, they're asking us to say how many different four-letter arrangements are possible using any two letters from the word smile and any two letters from the word frog. So if you look, it says that they want two letters from smile and there's 5 letters to choose from. And they're saying any, so it doesn't matter which ones you choose, so C2. So it's going to be 5 letters in smile and you're choosing 2. The word and means multiplication when it comes to math. And then finally we have 4 letters in the word frog and we're choosing 2 of them. So the answer would be 60. At a meeting, every person shakes hands with every other person exactly once. If there are 36 handshakes total, how many people are at the meeting? So this is where we say there's n people and we need 2 people to make a handshake. There were 36 handshakes in total, so we're going to solve this by replacing nc2 with n factorial over n minus r, which is 2 factorial, and then 2 factorial, which is r factorial. This is equal to 36. So if you count down, what you'll notice is that after n comes n minus 1 and then n minus 2. So we stop there because we'll see the exact same factorial at the bottom, which means that they can cross each other off. And then what we're also going to do is that 2 factorial is going to multiply to the other side. So we're going to bring that 2 factorial to the right side of the equation. So now we have n squared minus n when we distribute the n into the brackets. And on the right side, we should have 36 times 2, which is 72. Now we're going to bring the 72 over so that it's a quadratic equation. 2 numbers that multiply to negative 72 and add up to negative 1 would be n minus 9 and n plus 8. So that means that n could equal either 9 or negative 8. N is not allowed to be a negative, so we're going to cross out of that answer, and n is actually equal to 9 because there's going to be 9 people at this meeting. So we already started to look at Pascal's triangle, and that was when we did the pathway question. So where we had those boxes where if we look at the numbers, the side lengths are 1s. And then 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 1 is 3, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. So that's Pascal's triangle in this. So what we want to learn is how to expand a binomial. So this is called the binomial theorem. So if we have x plus y to the power of 0, anything to the power of 0 is 1. And then x plus y to the power of 1 is where you would remove the brackets and it would be 1x plus 1y. X plus y squared is when you would do FOIL. Now, as you get higher, it will be very, very difficult and very excruciating to try to do a distribution. So we have this kind of pattern that can help us write out the expanded form of a binomial squared, or a binomial to the power of 5, or a binomial to the power of 6. So this can make life a lot easier if we figure this out. So they're saying, what is the relationship between the value of n and the number of terms? If you look, our value of n is 0 in the first one, and our number of terms is 1. If our n is equal to 1, we have 2 terms. If our n is equal to 2, we have 3 terms. So what you should notice is that it's always going to be n plus 1 terms. So they're saying how many terms are in this expansion? Well, if we look at our n value is 8, so 8 plus 1 equals, there's 9 terms. So it's always 1 more than your power. So 14 plus 1 equals 15 terms. And finally, 5 plus 1 equals 6 terms. So that's how many terms we should have if we properly do this. In this one, they're saying that there are 17 terms in the expansion. So we know that if we have n plus 1, so 2k plus 1, if we add another 1, that's going to give us 17. So there's 17 terms in this expansion. So what we're trying to do is solve for k. So what is the value of k? So 2k plus 2 equals 17. Then we're going to subtract 2 on both sides, which gives us 2k equals 15. And then we're going to divide both numbers by 2, which means that k equals 7.5. So if we look at Pascal's triangle, what you'll notice is that when we're in the first row, we're using combinations to figure out NCR. So we're trying to rewrite it as NCR. So in the first row, we have 0, choose 0. And then in our second row, it's 1, choose 1, and then 1 choose 0, and 1 choose 1. And then when we're in the third row, we start with 2 choose 0, then 2 choose 1, 2 choose 2. So your n value, when we're talking about n choose r, your n value stands for what your n value is. So that corresponds to the n in your binomial. And then your r corresponds to starting from 0 and counting up until n equals n. So if we're trying to do a general term equation, we're going to use term k plus 1 equals n choose k, x to the power of n minus k, y to the power of k. So if we're doing our expansion, what you're going to just want to do is make sure that you start with n, look at your n, and then you're going to start counting your r values up from 0 all the way to that n value. Your x's are going to decrease from that n value all the way to 0, and your y's are going to increase from 0 all the way to 1. So if you follow that pattern, it becomes easy to expand these. So for example, number 3a. We know that our n is 4, so we're going to start with 4, choose 0. So that's our first combinations. And then our k value, our x value is always going to be x, which in this case, our first term is always our x and our second term is always y. So instead of writing x next, we're going to replace it with 3x. So this is our x, this is our y. It's always going to be x plus y. So we're going to replace x with 3x, and then we're always going to start with the n value, which is 4. And then our y value is 2 to the power of what, starting from 0, so to the power of 0. So that's going to be our first term. Our second term is going to be 4, choose 1, 3x to the power of 1 less than the previous value, so it's going to be 3. And our 2 to the power of 1, so that's 1 more than the previous term. And then we keep doing that pattern. 4 choose 2 will be then 3x to the power of 2. So as you can see, it went 4, 3, 2 for your powers. And then for your y, it's going to be 2 to the power of 2 as well. Then we have 4 choose 3. 3x to the power of 1, and then 2 to the power of 3. Plus, our final term is 4 choose 4, where now 3x is to the power of 0, and 2, which is your y coordinate, is to the power of 4. And that's when we've completed this. We know that we've done this properly because, as you can see, there are in total 5 terms. It's always 1 more than your n value. So n is equal to 5 for A. So now it's all about simplifying this. So what you should know is that 4 choose 0 is like multiplying by 1, so we don't need to write that. 2 to the power of 0 is 1, so we don't need to worry about that either. So all we care about is 3 to the power of 4, which we have to distribute, and x to the power of 4. So you'd put 3 to the power of 4, and that would give you 81. And then x to the power of 4. So that's your first term in the expansion if you've done it properly. Then we have 4 choose 1. So 4 choose 1 is actually 4. And then we have 3 to the power of 3, which is 27. and x to the power of 3. And now we have multiplying by 2 because 2 to the power of 1 is 2. Plus, that's our second term so far. So we still need to simplify further, but I'm just going to go to the next terms. 4 choose 2. 4 choose 2, so you'd put that into your calculator, equals 6. And then we have 3 to the power of 2, which is 9, and x squared. And 2 to the power of 2 is 4. And now so we're on our fourth term now. 4 choose 3 is 4. And then we have 3x, because to the power doesn't change the value. 2 to the power of 3 is 27. Oh, sorry, 2 to the power of 3 is 8, actually. And then we have 1, so this becomes 1, so we don't have to worry about that. 0, anything to the power of 0 is also 1, so all we care about is that 2 to the power of 4, which is 16. So now we're going to completely simplify. 81x4, and then we're just going to multiply all those numbers together. 4 times 27 times 2 becomes 216. X to the power of 3. And then we're going to multiply the 6 times the 9 times the 4, and we get 216 again. So as you can see, the powers are decreasing as if we're expanding properly. So that's showing us we're on the right track. And then after 216, we're multiplying 4 by 3 by 8 to get 96x. And our last term is 16. So this is the proper expansion. If you were to do the expansion of all that, that's what you would get. So this is a strategy to figure out how to expand something where FOIL becomes too much and it becomes too complicated. So that is for A. For B, we know that the n value is 3. So we're actually going to have 4 terms if we're doing this properly. So we're going to start with, for B, 3 choose 0. And then in brackets, our x value is the value that goes in front of the x as well. So 2x, and that goes to the power of 3. And then we have to include the negative as well. Normally, we always have x plus y. So if you see a negative, put that into your y value. So negative 3y to the power of 0, and that represents our first term once we simplify it. Plus, now we're at 3 choose 1, 2x to the power of 2, because we're counting down, and then our power for y counts up. So negative 3y to the power of 1, plus 3 choose 2, 2x to the power of 1, and then negative 3y to the power of 2, plus 3 choose 3, our last term is 2x to the power of 0, and negative 3y to the power of 3. So that is before we've simplified. Remember, all these we can cross off because they just become 1. So 2 to the power of 3 is going to be 8, and then we have x cubed. So that's our first term. Our second term will be 3 choose 1 will be 3 times 2 to the power of 2 is 4, and x to the power of 2 is x squared. And then we still have negative 3y. Now our third term, 3 choose 2, is going to be 3. And then we have 2x multiplied, or to the power of 1 doesn't really change. And then negative 3 to the power of 2 is actually going to be positive 9, and then y squared. And our last term is going to be negative 3, which is negative 27, y to the power of 3. So that's simplified. Now we still have to put all the coefficients together by multiplying them. So the first one is going to be 3 times, or the second term is going to be 3 times 4 times negative 3, which is negative 36. So in between the signs, you should have negative 36, x squared and y, plus 3 times 2 times 9 is 54x y squared. And then we have minus 27y cubed. So that's your expansion from the binomial. And now we're on to our last one. So the last one, we have a fraction, so we're going to have to watch for that. Our n is equal to 5, which means that there's 6 terms in this one. Okay, so it's going to be, our first term is going to be 5 choose 0, 2x to the power of 5, and then negative 3 over x to the power of 0. Next term, 5 choose 1. So what you're looking at is that the pattern and seeing what the pattern is and just following it to complete each term one after the other. So this is 1 less for x and 1 more for y. So that should be a 3. And our last one is 5 choose 5, 2x to the power of 0, and then negative 3 over x to the power of 5. So what we want to remember again is that these guys will just become 1, 1, so we can ignore those. Save ourselves some time. And our first term, so 2 to the power of 5 is 32. So we have 32 and x to the power of 5. Then our second term is actually going to be 5 times 2 to the power of 4 times negative 3 to the power of 1. So all those numbers will actually multiply to give me negative 240. Okay, so in your calculators, what you're doing is 5, which is 5 choose 1, times 2 to the power of 4 and times negative 3. So negative 240. And then we have x4 divided by x, just x. So that will simplify eventually. So any variables at the top will simplify with the variables at the bottom. So that's our second term. We still have to simplify that, but we will do that in the next step. And so now we're continuing on. We're going to go 5 choose 2. So 5 choose 2 is 10. So it's going to be 10 times 2 to the power of 3 times negative 3 to the power of 2 in brackets. And that should give us positive 720. So we're putting all the numbers together, including those exponents. And then we have x to the power of 3 over x to the power of 2 now. And now we're on the fourth term. 5 choose 3 times 2 to the power of 2 times negative 3 to the power of 3 should give me a negative number. So you should see that if you're doing this properly, you should have a positive, negative sign. And that's how you kind of know that you're on the right track as well. So 5 choose 3 times 2 to the power of 2 times negative 3 to the power of 3 gives me negative 1080. And then we have x squared over x cubed. And then we have so far, we have 4 terms, but we need 6 terms. It's always one more than n. So our fifth term is going to be positive 810, because that comes from going 5 choose 4 times 2 times negative 3 to the power of 4. And then we have x over x4. And our last term should be a negative 1 if we're following the pattern. Negative 3 to the power of 5 should be negative 243, and at the bottom, x5. So our final answer we're just simplifying the values of the variables. 240 x4 over x will give us x cubed. So we're just subtracting an x from the top. Plus 720 x. And then we have minus 1080 x over x to the power of 1, because as you can see, there's more x's in the denominator, so there's 1 left over in the denominator. Plus 810, and then we have x3 in our denominator. And finally, minus 243 with x5 by itself in the denominator. So that would be our final answer, because I prefer always to have those positive exponents. So that's our answer once we simplify. Example number 4, they're saying determine a simplified expression for the 8th term. So this is where we can use the equation that was bolded. So this is on your formula sheet as well. So we want to rewrite this first of all and use that, because that will help us jump instead of rewriting every single term and then just figuring out what the 8th term is. It would make sense to use this equation. Okay, so remember, this is your x, -2 is your y, and this is your n value. So when we're putting this in, it's going to be, we know that k actually represents k is going to always be 1 less than your number of terms. So it's going to be n minus 1. So that's how we get that. So n minus 1 is your k value. We know that there are 8 terms, so you'd go 8 minus 1 to get your k, which is 7. So term 7 plus 1, which makes sense because that would give us term 8, equals n, which is 11, choose k, which is 7. Our x value we're going to replace with 3x to the power of n minus k. So remember, n is equal to 11, k is equal to 7. So 11 minus 7 is what we're trying to do to get that answer for the exponent. And then -2 is your y coordinate, and your k is 7. So this is what we need to simplify, and once we do, we will get the answer. So 11 choose 7 is actually 330. Then we have 3x to the power of 4. And -2 to the power of 7 is -128. And now we need to multiply these values together. So I'm going to put in my calculator 330 times 3 to the power of 4, which is 81, times -128. And that gives me my coefficient for that 8th term. And so that gives me x to the power of 4. So this is the actual term, or the value that is in the 8th spot, 8th term. So this is what I would have as the solution. Now they're saying determine the coefficient of the term containing ax squared y5 in the expansion of x minus 3y7. So we want to determine the coefficient. So again, we're going to use the previous formula. So what we can see is they're giving us some little hints, because we know that our k value is 5 just from this. So k is 5 because, as you can see, y to the power of 5 corresponds to what y to the power of k is. So k is 5. Now we can say term 5 plus 1 equals, n is always going to be the exponent on your binomial, which is 7. So it's going to be 7 choose 5. And then our x value is x in this case, and it's going to be n, which is 7, minus 5. 7 minus 5 is 2. And -3y to the power of k, which is 5. Okay, so that's what we have so far after substituting what we can, and we just need to simplify it until we get the coefficient. So we're looking at term 6. So term 6 is going to be 7 choose 5, which is 21. And then negative 3 to the power of 5 is negative 243. And then we have y5. So as you can see, these coefficients will multiply together to give us negative 5,103 x squared y5. And now it looks like that. The above ax squared y5, and our a value is equal to negative 5,103. So there's our coefficient. Example number 6, they're saying determine the simplified expression for the term containing x to the power of 3. So here we know our n value is 6. And then when we're doing this, we know that we have to have x to the power of 3. So something minus another thing will have to give us 3. Well, that's what our k value is. So remember, it's always going to be n minus k equals the power for x. Well, 6 minus 3 is the only way that we can get 3 as a power of x. So we already know now that k is 3. So now I'm going to substitute it into our formula. T term 3 plus 1, which is k plus 1, equals 6 choose 3. Our x value is 2x to the power of 6 minus 3. So that's how I figured out that it had to be 3 for your k value. And then your y value, which is negative 3, has to be to the power of your k value, which is 3 as well. So 6 choose 3 is 20. And then we're going to have 2x to the power of 3. And then negative 3 to the power of 3 is negative 27. So we're going to multiply 20 by 2 to the power of 3 by negative 27, and we should get negative 4,320 x cubed. So that would be actually term 4. So they're saying determine a simplified expression for the term containing x cubed, and there you go. That matches up with the term. Example number 7. So they're saying find the constant, the term independent of x, in the expansion of 2x minus 1 over x squared to the power of 15. So we're going to start with the equation again for a general term. Tk plus 1 equals, we know that our n is 15. We don't know what our k is. Then we're going to substitute 2x for our x value, and it's going to always be n minus k, which is 15 minus k. And then we have negative, so it's going to be negative 1 over x squared is replacing our y spot, to the power of k, which is unknown. So we're going to try to put all the k's together, and once we can figure out what k value would be 0 where it disappears, what would make the exponent equal to 0, that would be then the value that we would use to get the constant term. So we're going to try to simplify this as much as possible. So we're only really caring about the x's right now. So my hint to you is only look at the x variables. So anything with that x variable is what I want to combine. So I know that it's going to be then x to the power of 15 minus k, and then I have to summarize it and simplify it with negative 1 over x squared, which will distribute that k into the top and to the bottom. Okay, so what we have so far is x to the power of 15 minus k, and then negative 1 to the power of k. We can really ignore that and just leave it as 1, because what we'll do is we'll flip this fraction to be on the same level. So we'll go x to the power of negative 2k. So we're ignoring this part because it doesn't have the variable of x, so we just care about the bottom right now, bottom. So what I'm doing is I'm flipping it, and all that happens is when you flip a fraction, when you flip a fraction, it just becomes the negative exponent. And then we're going to put these numbers together. So whenever we have two x's multiplying, we're going to add the powers together. So 15 minus k, we're going to add negative 2k. So that's going to be x to the power of 15 minus 3k. Well, we're trying to figure out when that power equals 0. So we're going to take 15 minus 3k equaling 0 and solve for k. So what k value would make that happen? Well, if I bring 3k, that negative 3k to the right side, it becomes positive 3k. Then divide by 3 on both sides, and you'll see that k is equal to 5, and that's the only way that that variable of x will disappear and become 1. So we want that whole variable to go away for it to be a constant term with no variables. Once we have now k, we can go back into the original expression over here and replace k with 5. So we're going to go term 5 plus 1 equals 15, choose 5, 2x to the power of 15 minus 5, which is 10. And in brackets, we have negative 1 over x squared to the power of 5. So 15 choose 5 is 3003. 2 to the power of 10 is 1024. And then we have x10. And then negative 1 to the power of 5 will still become negative, will still stay negative 1 over x to the power of 10. And as you can see, these x to the power of 10s will cross each other off because one's in your numerator, one is in your denominator. And so all you have to do is multiply the coefficients together. So that's going to be 3003 multiplied by 1024 multiplied by negative 1. And we get that the constant is negative 3,075,072. So that's our constant in this expansion. So that's the one without any variables. Here they're saying one term in the expansion is this, where we have negative 15, 120, x4, y cubed. They're saying determine an expression to solve for m. So we'll put this into our actual equation where our general term, which is k plus 1, is equal to always our n, which is 7, choose k. And we actually know what k is. The reason is k is always the power over your y value. So we can use that to simplify, where it's going to be term 3 plus 1, which is term 4. So 7 choose 4, or 7 choose, 3. And then we'll put 2x, which is our x value, to the power of 4. That's how we're going to get that x to the power of 4. And then our negative m is going to be to the power of 3. So what we want to do is solve for the m. Our term 4, we actually know the value is going to be negative 15,120 x4 y cubed. And then 7 choose 3 is 35. 2 to the power of 4 is 16, x4. And then we have negative m to the power of 3 is just negative m to the power of 3, like that. We can distribute it. Okay, so we're going to multiply all the numbers together. So that's going to be, on the right side, 35 times 16 times negative 1. Gives me negative 560. And that's x4 and then m3 so far. The left side stays the same. Now we're going to divide both sides by the x4 and the negative 560. So we're trying to get and isolate for the m. Okay, Okay, so as you can see, the x values cross each other off. And then in our calculators, we're putting negative 15,120 divided by negative 560. So we get 27. Y cubed equals m to the power of 3. Now we're going to cube root both sides to solve for m. When you cube root 27, you get 3. When you cube root y cubed, you get just y. So that is what your m value is. So determine the expression to represent m, which is our value of 3y. Okay, so that is it for